Welcome to the second Haglof webinar covering some functions that we specially developed for height measuring in the Vertex Laser GEO instrument. Today we will cover 4 different functions and it will be mainly how to measure trees, but these functions can be used for any height measurement, so it doesn't matter that much, but we'll explain how the instrument handles these functions, how they work in the instrument, and when they can come in useful. Give some examples of different scenarios. If you have questions during this webinar, there is a query on your right screen, so you can write any question that you have, and we can look at covering that after the presentation is over. Or you can also send us an email and we will reply to that as fast as we can. Okay, we will start with the presentation. So the Vertex Laser GEO. The Vertex Laser is actually a unique instrument, and the instrument has unique functions. And to better explain how it works, I will go through the different sensors that the instrument has and how they are used and how they are combined in different methods. But the Vertex Laser in general is a small hand-carried device that has a very low weight, is rugged and can work in any weather condition, and it combines 2 measuring methods for distance. First of all, the instrument, to go through the instrument. Okay. So, starting with the sensors. The instrument has a tilt sensor that is brought in every function, I would say, that we use in the instrument. Is very central in all the measurements, and this sensor is on 0.1 degree accuracy, so it is accurate. Then you have the laser rangefinder, and that is used from about 0.5 meter up to 600 meters, and the precision of the laser is ±4 centimeters, so it's a very accurate professional laser. Then the second method to measure the distance is ultrasound, and how that is done is that you measure, instead of laser, it measures the speed of light, 300,000 kilometers per second. Instead you measure with sound, you measure 340 meters per second, and you measure the time that the sound travels. So with ultrasound, you need a transponder, what we will call T3 in this presentation, transponder 3. And the time is measured 2 ways for the sound to travel between the instrument and the transponder. What is good with ultrasound is that it can measure even if you have a dense forest, for example, a lot of undergrowth, and you can't clearly see the target. You can still measure with ultrasound because the sound goes around the trees and the branches. With laser, you will need to have a clear vision of the target, otherwise you will get the incorrect measurements. With ultrasound, it's only the transponder that can respond to your measurement. So either you get the result and that's correct, or you will not get a result. But the distance is here also a limit. So you can measure from, let's say, 10 centimeters up to 30 meters with ultrasound. So it's shorter distance. And also, we'll come into that more, but you need to calibrate the ultrasound according to the different temperatures over a day and the conditions where you're measuring. So you should always make sure that you calibrate before starting your work day. Laser will not have to be calibrated. Okay, then there is a compass built in, and this compass is also accurate, 1.5 degree plus minus. The compass can be tested in a special menu in the instruments, and it can be calibrated, but make sure that you check and test the compass before starting to work, because it can be disturbed by surrounding environment or metal objects or your phone or something like that. Then there is a GPS receiver built in the instrument, so you can actually position where you are standing in relation to the target. So all the time you can not only store the target and the value for the targets, but you can also store where you are standing in relation to the target. And this comes in really handy. There is also a possibility, if you need, maybe for a project you have a need for a very accurate position of your own position, then you can connect this unit. Instead of the internal GPS, you can connect it to a sub-meter GPS. For example, the geode is a very good from Uniper that we tested a lot. But you can, any Bluetooth GPS works. Then you can store data internally in the instrument, and that is done easily, storing the data, but you need to activate that in the unit. So either you store the data or you can send it also by Bluetooth. The unit has built-in Bluetooth, and this BLE that we are using in the instrument, a newer type that works longer than the old traditional Bluetooth. So you can actually send, we tested, it says very long distance, but 50 meters is normally never a problem. So you don't need to be within 10 meters to connect to a device like a cell phone or something like that. You have USB in the GEO, and this can be used to charge the instrument. You can, for example, you can connect it to your PC and it will be charged all the time, or you can connect it to a standard plug a wall charger. And we recommend, for the fastest charging of the unit, you should charge it in the wall, because then it's 3.5 hours to a full charge. If you charge it in your PC, you will have it will take longer time. But you can also use a so-called emergency charger. If you're in the field, you charge it over this USB instead. On a full charge, you can easily work a full day and actually many days without having to charge it. Of course, the USB also is used to send data to your PC, what you have stored. Then there is a built-in battery, and this battery has a good lifetime, and it's a Li-ion battery. What we can say that it's never a problem. I came into that before, but to work several days in the field, even if you have all the sensors active, is working very good. It's a graphic display on the side of the unit, and this will give you a good vision of what the results you have of everything that you measured. And this we have had in the Vertex, for example, one of our models of the height meters, and also we have it in the Laser GEO. And now we have also not only the display on the side, but we have an OLED display, a heads-up display that will show direct in the scope the measurements and the results that you have measured. Okay. So, some functions we will cover today here will be the 1 point, the 3 point, the 3D vector, and the height DME, which is the ultrasound is used. Then what we also have in the instrument, but we won't cover here, is the compass, the angle, the map target, and the map trail. And then we had the webinar that we have had previous that did cover the functions for power lines, that is the line clear and the delta height function. For those of you that missed that webinar, please let us know and we will send you the link for that as well. So we start with our first function. The 1 point, actually this function, it gives you the height difference between you and the target. It's not the actual height of the target. And you should have assumes that you have a flat terrain to measure. But maybe also you're interested in measuring the height difference between you and the target. Then this is a very good function as well. So the 1 point laser gives you the height difference from you and the target. And then in this function also remember that we have a eye height that you can set in the instrument. And this eye height will be added to the result. So actually that is very important to remember, especially if you're many persons using the same instrument or you use it on a monopole, then it's important to remember that, check that you have the correct eye height setting, because otherwise you have a built-in error all the time. And the GEO also is an instrument that is, like I said, it uses this function. How this is possible is because we are always measuring the horizontal distance to, even when you measure with the laser, we're always measuring the angle. So that's how this function is available and how it's done. So the instrument is made to be optimized for freehand measuring, but you could of course as well use it on a monopod. Okay, so this function, to show you how it works. First of all, you step away from the object to measure so you clearly can see the top. Then you go to the height 1 point in the instrument, press on 1 time to select that function. Then you aim at the top and you press the on button, a short press, wait until you have a signal, hold the instrument steady until you have a signal. Then it has measured the angle and the horizontal distance and can calculate the height. So this is actually what is measured, and then it adds the eye height setting you have in the instrument and you will have the total height. So as you can see here, you get the slope distance, you get the horizontal distance, you get the height, and you get the angle, and you also get the compass bearing, which is the azimuth. Okay, it's important, as I said here, that you aim and press and wait for a signal. And the reason for that, and this is one possible error, if the first-time users that uses the instrument, that since we always measure the horizontal distance, it's easy to forget. When you press the on button, the laser will measure so fast, 300,000 kilometers per second is very fast, but it needs some time to capture the correct angle. And that's something that if you just measure and move the instrument, you will get the correct slope distance, but the horizontal distance will be incorrect, and then the height will of course be incorrect. So wait for a signal. Next function. This function, the 3-point, we call it, height 3p, is actually the one that we recommend mostly in forestry. And this function gives you the actual height of the target, even if the target is standing on a hill and you are down in a valley, or vice versa. So this will give you the correct height of the target. The previous function gave you the height difference. This is the height of the target. So it is useful in most cases in the forest. You will only have to make sure that you can measure one distance with the laser to anywhere on the stem, in this case of the spruce. So first of all, you see the sensors that are used and brought in this function is the tilt sensor and the laser rangefinder. So we're going to measure this spruce tree. So we select the 3p function in the instrument, press the on button to select it. Then we step away as far from the tree until we can clearly see the top. On a spruce tree like this, many times branches can hang down all the way to the ground. I'm sure you've seen those cases. Then it can be good with this function that you can also take your laser measurement to the top, because that is straight under the stem. So then the instrument will actually calculate the horizontal distance will be correct. So even if you can't see down to the base, this function can be used many times. So how it works, I take my first measurement, press the on button, a short press, it's laser, and when that is ready, I aim the base, press the on button. Now I keep the on button, I hold it down because it's angle measurement. And I measure until I have a signal, I hold the button down. Now I aim the top, I hold the button down again, it's angle measurement, until I have my height. And this is the actual total height of the tree. If you want to store this information, of course, that's also possible. So when I have done my measurement, you can see here that you have all the information. You have the slope distance, you have the horizontal distance, and you have the height angle. In this case, 27.3 meters. I want to store that. I send it to the memory. So I press the send button. It will give me the file identity, which I will see when I open this afterwards. Then I press the on button. It will activate the recording of the GPS. And then I press on again, and it will store the position with the GPS where I'm standing, and it will store the tree in relation to my position to the local SSD drive. Then I can open that as a KML in Google Earth, or I can open the CSV file in Excel or in other softwares as well. Okay, just to give some examples when this function can be good. In this case, the tree is standing higher than me. I'm down from the tree. Doesn't matter because this will anyway measure the tree where it's standing. So I aim my first shot to the tree stem. It calculates the horizontal distance for me. And now that was done with laser. So short press, wait for the signal, aim the base, measure the angle, hold down the button until you have a signal. It's measuring several angles actually. No matter if I'm shaking, it will calculate the average angle, very accurate. So then when I have the signal, I measure the top, hold the button down until I have a signal, and it presents the same as before, the height. Now I'm standing over the tree in my next example. So in this case, I'm standing on a hill and the tree is down in a valley. I can still get the correct height. So how I do it is that I select the 3-point, press on, then I aim anywhere on the stem. In that case, I found the space there, and I press the on button a short time, wait for a signal, and I get the horizontal distance. Then I aim the base. Now it's angle measurement, so I hold the on button down until I have my signal and it's calculated the correct angle. Then I aim the top and hold the button down until I have a signal, and it presents my height. If I want to take, maybe in this case I would like to take a green crown height, or I would like to take, I have a damage on the tree, I can just continue down the tree and press and hold the button down, and it will give me a second height, and even a third and a fourth and a fifth height if I'm interested in dividing the tree into two sections or things like that. So that's also possible to do with the Vertex Laser GEO. Okay, so height 3 point was that. Then we come to our third function for measuring tree heights. And here in this function, HEIGHT DME, we're using ultrasound instead of laser to get the distance. And now how this is done, I mean, this function is, why should I use this function instead of using laser? Because I have to use a transponder. But it's because if you have a lot of undergrowth, a lot of branches, a lot of grass or whatever on the ground, ultrasound, as I explained earlier, will work very good in most cases. And laser will not, because the risk of hitting the wrong target is very high. So you will have to go with the transponder actually to the tree, set the transponder at the tree stem, and then start with your measurement. So that's pretty much the difference from using laser. With laser, you don't need to go to the tree. Okay, so I want to measure this tree. Then I go to the tree and I activate the transponder. The transponder has a 1.5 volt AA battery in the unit that can be changed at any time. It will run for several months actually. But you put it on the tree once it's activated, and you put it in breast height. But you can set any transponder height in the instrument. This height will be added to the measuring result. So if you put 1.3 meters, that will be added to the total height. Then I step away from the tree until I clearly can see the top. I need to visually see the transponder, but it doesn't need to be a clear view to the transponder. It can be a lot of things in between. I select HEIGHT DME, that function, press on. Then I aim to the transponder and I press and hold the on button down. Now I measure with ultrasound. So it measures the distance to the transponder. The transponder sends the signal back to the unit, and the time is measured two ways. And from the time, the distance is calculated. Now I have my horizontal distance to the transponder. I aim the treetop, hold and press the on button down, and it will actually calculate the height between the transponder and the top and add the transponder height that I set in the unit. Next scenario, and of course with this function as well, I can cover that in this picture actually. This is the second scenario where the tree is standing down, and you do the same, put the transponder, select the HEIGHT DME. You have a lot of things in between, so you can't really see. You use the ultrasound. Measure, hold the button down. It measures with ultrasound the distance to the transponder. I aim the top, measure the angle to the top, hold the button down all the time, and it will calculate my tree height. And it will be the correct tree height where the tree is standing, no matter I am higher than the tree. If I want to store this now to the memory of the unit and send it, it's for sure it's the same as, it doesn't matter if you use ultrasound or any of the other functions. The same way, press send, it will give a file identity, press the on button to start recording with the GPS, and when you're satisfied with the number of registrations, you press the on button again and it's stored to the memory of the unit. Okay, and third scenario would be if you were standing under the tree or lower than the tree, aim the transponder, press and hold the on button down, measure the distance to the transponder, horizontal distance, aim the top, hold the button down until you have a signal, and it will calculate the height. One thing working with ultrasound also, I think I mentioned that, but you could sometimes run into problems if you have insects or you have, it could be birds or you're very near a power line or something like that. But as I mentioned, it could be easily just move a couple of meters or up to 10 meters and it works perfect. So, but be aware that heavy rainfall or things like that could trigger the transponder. It's nothing wrong with the unit most cases, but it will not, as I said, give you a small incorrect reading. Either it gives you a result or none at all. So the fourth function and the last function that we will cover today is the 3D vector, and this function in the unit is not only for tree height. It can come in handy in many cases, and we've seen that in other projects, but it's when measuring and when you're interested in the relation between two target points. For example, in this case, I will quickly go through some of these cases. This is to measure a green crown width. How wide is the green crown? If you have a tree that is leaning, not standing upright, can be a very useful function. If you have a slope in the terrain, it will give you the relation between the two measuring points, so it gives you the slope angle. And a case where you want to know how wide is a stream or how wide is a river, at some points you could use this function. The 3D vector, as I said, is a function that brings in all the sensors of the unit. And from two measuring points, you will have all vectors, not only in this case you will see. So I will show how this works. You step away from the tree in this case, so you see the 2 points that you're interested in. And you select the 3D vector function in the instrument by pressing on, and then you aim your first target point. In this case, I press on, and it's the left side of the tree. I press the on button, a short press, and I get the signal that the measurement has been done. Then I want to send this to the memory because this is a function. So I press the send button, and my first point is stored. Now I aim at my second point. I press the on button, I wait for the confirmation signal, and then I press the send button again. Now the instrument calculates the information for me. And actually what I will get here then from these two measuring points, if you look at my two measuring points there, you have a yellow line, and that is the slope distance. Then it will also give me the horizontal distance, and it will give me the height relation between the 2 points. It will give me the angle of this yellow line, the slope, from point A to point B. What's that slope? And it will also give me the compass bearing from my first measuring point to the second point. And this can be very useful in many cases. So you get a lot of information from these two measuring points. And of course you can store this, so if you press the send button now again, you will send the data to the memory, because what you did before pressing send is that you keep it for the calculation of this measurement. But you send to the memory, then you press the on button and you activate the GPS and you press the on button again to store it for the future as a KML or a CSV file. Okay, the second scenario what we had is this slope. I want to know some information about this line here in the forest. So I take my first measurement anywhere where I'm interested. I press the on button, measure down, and then I press the send button to send it to the local memory. I aim my second point, press the on button, and then I press send again. And it will calculate. In this case, I was interested to know the slope distance between the points. But I will also get this information. So you see here, I get the height relation of the points. That's the red line there. I will get the horizontal distance. That's the blue line. And I will get the compass bearing between the points as well, if I was interested in that. So a lot of information from only two measuring points. And I could, of course, store this as well. Third scenario, if I would like to measure how wide is this river, I aim somewhere my first measuring points. Once I've selected 3D vector, press the on button, and measure my first point there on the left side, press the send button, aim again on my right side and press the send button, and I get the information. I get all the vectors, not only here I was interested in the slope distance, but I will also get, you see, all the other information like relations between the points. And my fourth scenario here would be a leaning tree. So actually, if I would use any of the other functions that I showed, the HEIGHT DME, the 3P, or the 1 point, they will give me the height, assuming that the tree is standing upright. With the 3D vector, I can actually measure the length of the tree, and I will show it here. But you need to have a clear line of sight to the top and the base of the tree. So first of all, I select the function, aim the base, and I take my first measurement at the first point down the base. I send it to the memory. I aim the top, and I press the on button, and then I send it to the memory. And now the instrument will calculate this information from those two measurement points. The yellow line that says slope distance is actually the tree length. The red line is what I would get from, let's say, the 3 point. That's the height, assuming that the tree is standing upright. And then you have the blue line there is the horizontal distance. Okay, that was the functions that we will go through here today. First of all, we have, it's important what you are measuring now. I say you can store it to the memory, you can create these type of files and everything. And we would like to show a short film because we have developed an app that works both for iOS and for Android devices that is free for download, called Haglof Link. And there you can directly in the field get the information from the measurements that you have done, so you can extract the files there, or if you want to send them for further processing. So the film, about Haglof link. So this is how it works. Once you have your files or your measurement in the unit, you connect it with Bluetooth, and you will see the device, your device, coming up on the screen as just connecting anything to a Bluetooth file. It works really easy with the file transfer, and then you send your files. And as we said earlier, it's the format of the files is CSV or KML. And here you can see the list of files. So if you want to open them, for example, in Google Earth, you can directly do that on your phone or on your tablet. What is showed there is actually measurements done on a pile. And I can mention now also that our next webinar will be about this system with map target and how the method to measure irregular objects and to show our cloud-based solution pits and piles. So if you're interested in that, it will be a good webinar to join. But the Haglof link, I can recommend that. It's free for download on App Store or on Google Play. And if you happen to have a GEO that you've been working with, it's just to send over the information through the use Haglof link. This film that we're showing now is also available on YouTube for you to look at later how that works. And the Haglof application cloud has different services, applications that can be used, and what we have now is, for example, this pits and piles to measure irregular and get the volume and to store and share data. It's a cloud-based solution. So next time we have the webinar will also be about this pits and piles solution available on the cloud. Okay, glad you could join us and hope you found today's webinar interesting. Let's see, did we have any questions? If you have questions, you can just send us an email and we will share this presentation also if you want to use it afterwards. Thank you very much. We will get back with more webinars.
I have one question.
Okay, there seems to be a question.
Will it be possible to send the measurement through Bluetooth real time?
Alltså now.
Live alltså. Att du mäter vilka blodtankar hela tiden.
Ja, det beror på hur man ser det. Okay, we had a question if it's possible to send Bluetooth data by Bluetooth real time. It's possible, but I think it's more up to how the application. Then you need to see the unit, but it should be possible. Yeah. Please write more about that request, or if there is some more information around that directly to us, and we'll try to answer it better. But it's possible. So we are gonna close here for Eastern holidays here in Sweden. So I wish you a really good Easter and thanks for listening. Thank you very much.